Hello, we are Team MAVRIC, and we are pleased to demonstrate our rover for the 2024 University Rover Challenge. Since 2019, we have been iterating on this core rover design and are pleased to show how our new upgrades make us more capable than ever before. This video will show how our rover approaches the missions of URC. To detect for signs of life, we have modified two Hygenia swab-based systems for use on board our rover. The first system uses ATP luminometry using luciferin and luciferase reactions. The second uses the Barrett reaction to detect proteins. A deeper discussion of the reactions is provided in the science page of the written SAR. As is being demonstrated, our process for taking multiple samples starts by collecting a thin layer of dust on one of our 4 sterile aluminum plates. The sample is then swabbed from the plates, first for luminometry, then for protein. The swabs are resealed and the reagents squeezed from the bulbs of the swab, activating the reaction. In the case of luminometry, the swab is then inserted into the luminometer for analysis, or, in the Barrett reaction, the swab is held in view of the camera to observe the color change. While our soil stratigraphy mechanism has not been fully integrated onto the rover yet, we have constructed prototypes of our design and have settled on a promising model that utilizes an auger to fill a graduated cylinder for viewing and drive a soil temperature and moisture sensor into the dirt.
The mechanical team has spent the last year improving the suspension, arm, and science systems. The arm has been redesigned to reduce slack and to improve maneuverability. The shoulder pitch is controlled by a rack and pinion system, which has an accuracy of 0.5 degrees. This precision gives the operator much better control of the arm during the equipment servicing missions. We have also redesigned our end effector to increase our speed during the equipment servicing and delivery missions. A new analog camera allows us to see up close during our arm movements and observe objects. With the slip ring on our wrist, the camera will continuously spin 360 degrees with the end effector. Our equipment servicing claw contains recessed features to assist during switch flipping and flat features to help center the end effector around various objects. The delivery claw is designed with grips to grab handles and manipulate objects in the field.
The redesigned suspension system enhances both rigidity and maneuverability. It features a 6-wheeled configuration comprising of 3 bogies and 4 steering motors located at each corner wheel. Notably, the steering motors have been repositioned above the wheels to enable precise control, eliminating the negative camber associated with their previous placement. This adjustment also bolsters the rigidity of each suspension member. Constructed from G10 fiberglass and carbon fiber reinforced PETG, the suspension components are lightweight yet robust. The new positioning works in tandem with our new wheel design. The wheels are 3D printed with a soft and rigid section and feature a larger diameter of 10 inches. The increased diameter creates a 60% larger footprint than the old system and a 15% larger coefficient of friction. These both help the rover maneuver terrain better, and the larger diameter allows the rover to roll over larger obstacles.
Systems team has been busy upgrading the rover's electronic hardware to improve our autonomous performance. A new GPS system keeps us on track by giving us half a meter of positional accuracy, and our compass's new calibration method keeps us within 1 degree of our target. These upgrades result in a more accurate and reliable autonomous, allowing us to repeatedly reach waypoints within the 2-meter target range. Our OpenCV Uruco detection method interfaces with our autonomous state machine to locate and navigate to the target. We have also completely reworked our base station, prioritizing efficiency and reliability. It now interfaces directly with the ROS instance, removing an additional point of failure in our old socket system. Disconnects no longer require restarts and are recoverable whenever they occur. Every ROS topic is easily accessible through our debug panel, allowing us to diagnose software issues in the field. The base station has special features for autonomous. It syncs the waypoints list and status with the base station so waypoints can be easily added, reordered, or removed.
I would like to thank our sponsors for the 2023-2024 season: Iowa Spacecraft Consortium, Make to Innovate, and Scrap Processors of Iowa. And a special thanks to Hygenia for their scientific consultation and donation of product. I hope that we provided a compelling demonstration of our rover. Thank you for considering us for the 2024 University Rover Challenge.